Alright guys, we're back to talk about a powerful tool for you to use in solving equations, and that's going to be fraction busting. This is section 3.3.2, equivalent equations and fraction busters. So let's get right into it here. Let's back off that a little bit. Two equations are equivalent if all their solutions are the same. There are several ways to change one equation into a different equivalent equation. Common ways include adding the same number to both sides, subtracting the same number from both sides, multiplying both sides by the same number, dividing both sides by the same number, and rewriting one or both sides of the equation. For example, the equations below are all equivalent to 2x plus 1 equals 3. So let's figure out how that is. So to go from 2x plus 1 equals 3 to 20x plus 10 equals 30, we would multiply this all by 10. So if we took that one, we multiplied it all by 10, that becomes 20x plus 10 equals 30, which is what we have right here. If we were to factor a 2 out of here, in other words, divide 2x and 1 by 2, we would get the second one here, which is 2 times x plus 1/2 equals 3. You can sort of see that if you distribute this to both of those. 2 times x is 2x, 2 times 0.5 is 1, and it still equals 3. Or we could divide everything by 3. So if we divided 2x by 3, we get 2x over 3. We divide 1 by 3, we get 1/3. We divide 3 by 3, we get 1. That gives us that equation. Here's another version where we have divided everything by 1,000 and put it into decimal form. So if we do 2 divided by 1,000, we get 0.002x. If we do 1 divided by 1,000, we get 0.001, and 3 divided by 1,000 would be 0.003. So these are all equivalent expressions. So let's look at the example they give us here. We're going to use fraction busting to solve this example. This says solve x plus 3, let's start over. Solve x over 3 plus x over 5 equals 2 for x. So this equation would be much easier to solve if it had no fractions. Therefore, the first goal is to write an equivalent equation that has no fractions. To eliminate the denominators, multiply both sides of the equation by one of the denominators. So we have a 3 right here in our original equation. We're going to multiply both sides of this equation by 3. When we do that, we're going to get a big 1 right here. This is going to be 3 over 3, which will give us 1x plus 3x divided by 5 equals 6. Then we need to get rid of the 5, so we're going to multiply everything by 5, which will give us a big 1 right here. So this leaves us with 5x plus 3x equals 30. There is a way that you could do this in one step. Instead of multiplying by 3 and then multiplying by 5, you could multiply the whole thing by one number. And I will leave that to you to figure out what that number is that would give you, as a final result, 5x plus 3x equals 30. Then you solve it like a normal, two-step equation here, right? We're going to add these two together. We get 8x equals 30. Divide both sides by 8, and we get 30 over 8, which is equivalent to 15 over 4, or 3.75. So the number that's used to eliminate the denominator is called a fraction buster. Now the equation looks like many of the ones you saw before, and you can solve it the usual way. Once you've found your solution, remember to check your answer. So you can take this 15 over 4, plug it back in here for x, and you should get 2 once that's all done. So again, this is a pretty powerful tool. It makes solving these equations a lot easier because you don't have to deal with the fractions. So I have 4 problems for you to try on your own on the next page. Use fraction busting to simplify and solve the equations below. And you guys have fun with that. Pause the video, finish this up, and have it ready for class tomorrow. Have a good day.